saturation, or converting primitives into pixels, and shading, or determining the color and lighting of pixels. So rendering, pag sinabing rendering, ito ay proseso ng finalization ng isang digital na imahe o isang 3D na modelo na ginagamit ng mga anime user upang pagsamasamayin ang mga visual mula sa mga anino o lighting effect hanggang sa mga texture o makabuo ng isang modelo.
A few moments later.
So we're now proceeding to the cameras. So in 3D graphics, virtual cameras are used to define the viewpoint and the perspective of the scene. Transformations such as translation, rotation, and scaling can be applied to the camera to achieve various effects. So meaning, yung camera ay ginagamit para makita yung visual perspective ng isang bagay or tulad ng mga lugar sa pag-capture, pwede rin siyang magamit sa mga photography, nagpapasok na siya doon, and so on and so forth. So that's all for the cameras. Okay. So we're now proceeding to the texture. So textures are 2D images that are applied to 3D surfaces to add detail, color, and realism. So pag sinabing texture, andito lahat ng mga details ng isang images kung saan nakita lahat ng layer kung paano tayo gumawa sa Photoshop. Nandun na yung lahat. And ikaw nang bahala kung paano mo siya i-mix or may transform to realism.
I'll go.
So, the lighting or realistic lighting is crucial for achieving convincing 3D graphics. So, lighting, kung wala ito, walang mabubuong texture na maganda. So, lighting, it has something to do with the texture para mas maging presentable ang isang texture. Or let's say images. That's one of the examples.
Oh my God! Wow!
A few moments later.
So 3D math, a strong understanding of 3D mathematics, including vector and matrix operations, is essential for 3D graphics programming. So, ang 3D modelo ay isang makaagham o mathematical na representasyon ng anumang 3-dimensional na bagay. Ito ay hindi technical na isang graphic hanggang sa ito ay ipinapakita. So, maaari din natin ipakita ito sa isang modelo or maaari itong gamitin sa mga hindi graphical na simulation at kalkulasyon ng computer.
A few moments later.
The perspective camera is where things get interesting. This camera is more like real life, with objects in the distance being smaller. That said, it uses the same sort of pipeline as before. Internally, you define a view matrix exactly the same as for the orthographic camera. However, then the projection matrix is formed differently. In a perspective view of the world, objects get smaller in the image as they get further away from the viewer. Another way to say it is that if something is farther away, it needs to be larger in world space if it wants to appear the same size on the screen. This gives us the idea of similar triangles. y2 divided by z2 will be equal to y1 divided by z1, and so on. So perspective projection is going to involve division, but when we multiply a vector by a matrix, it's just some dot products, a series of multiplies and additions. This is where the fourth coordinate for our points comes into play. Up to now, this fourth value has always been equal to 1. We run a point through any set of modeling transforms and the fourth coordinate value of 1 is left untouched. This all changes with perspective projection.
This is called scanline rendering, first developed in 1967 at the University of Utah.
For a simple example, let's consider just one polygon. Our job here is to figure out how this polygon translates to filled pixels on a computer screen. So let's first overlay a grid of pixels to fill. The scanline algorithm starts by reading the 3 points that make up the polygon and finding the lowest and highest Y values. It will only consider rows between these 2 points. Then the algorithm works down one row at a time. In each row, it calculates where a line running through the center of a row intersects with the side of the polygon. Because polygons are triangles, if you intersect one line, you have to intersect with another. It's guaranteed. The job of the scanline algorithm is to fill in the pixels between the 2 intersections. Let's see how this works. On the first row we look at, we intersect here and here. The algorithm then colors in all the pixels between those 2 intersections. And this just continues row by row, which is why it's called scan line rendering. When we hit the bottom of the polygon, we're done. The rate at which a computer fills in polygons is called the fill rate. Admittedly, this is a pretty ugly filled polygon. It has what are known as jaggies, those rough edges. This effect is less pronounced when using smaller pixels, but nonetheless, you see these in games all the time, especially on lower power.
Oh my god! Wow!
A few moments later.
My name is Alvin Magpantay. This is my hour recording. 3D graphics programming, APIs, and libraries. Developer often use graphics APIs application interface like OpenGL, DirectX, or Vulkan to interface with the GPU o graphics processing unit and create 3D graphics. So, itong APIs or application programming interfaces, ito yung dito ka gumagawa ng mga mga program o application na 3D. So, example dyan, number 1 is OpenGL, DirectX, or Vulkan. Dito ako makakapaggawa ng 3D graphics ng mabilisan na goods talaga yung quality niya kasi pang higher talaga siya level. So, dito naman papasok naman tayo sa optimization. Performance is a critical consideration in 3D graphics programming. So, halimbawa, i-connect natin siya dun sa APIs and library. So, nakagawa ka na lang ng 3D ng nakabuo ka na ng application na 3D like inisip tayo ng isang games na 3D. So, ang bawa COD, 3D graphics siya. May siya VR tsaka AR reality. So, doon na papasok yung optimization. So, yung performance ng isang 3D graphics na ginawa mo, doon na papasok yung kung paano mo siya i-optimize, kung paano mo siya gagawing mas maganda at mas quality na like mga bug o anything na makakasira doon sa laro. Doon mo siya papasok sa optimization kung paano mo siya i-handle. So, doon naman papasok is yung animation. In addition to static 3D models, animation play a critical role in many applications. So, yan na. APIs, gumagawa ka ng laro. So, optimization, na-optimize mo na. Dito naman papasok yung animation. So, dito na yung mag-a-addition ka na sa mga 3D na like, mga effects, mga mga naiisip mo na ikaw yung bahala kung ano yung mas maganda sa tingin mo na mas mapapaganda pa yung ginagawa mong mga 3D o application na mas gusto mo pang idagdag. Doon na siya papasok sa animation para mas mapaganda at mas mapaayos yung isang mong proyekto o laro na gusto mong gawin. So, dito naman, sa 3D graphics programming, dito mong papasok isa pa yung physics simulation. In some cases, 3D graphics programming may involve simulation physics to create realistic intersection between objects in the virtual environment. Physics engine in NVIDIA physics and bullet physics are used for this purpose. So, dito naman sa physics simulation, like, yung example natin dyang laro ay na reality is itong yung mga zombie, may mga zombie, mga Call of Duty, like reality, may mga baril, mga doon, yung lugar doon, kung realistic talaga, like yung puno, kung titingnan mo yung puno, talagang para siyang totoo, na, kumbaga, parang nandun din sa isang game na yon na 3D, parang ikaw din yung nandun sa mismong laro, nasa loob ka, yung ganun yung pakaramdam, pag naka-realistic, yung nakikita mo, tsaka yung buo ng laro. So, yun, yung physics,
So balik tayo dun sa APIS, library, optimization, animation, tsaka physics, halos lahat sila magkakonekta. Ito yung mga paraan para makagawa ka ng mas maganda at mas maayos na 3D concept or 3D na application para sa iyong proyekto o gusto mong gawin na laro.
Wala kaming pakialam!
A few moments later.
I've always thought 3D graphics were magical. I mean, I've always known how to draw pictures, but how do you draw something so realistic in 3D? I mean, look at modding communities these days. People are making insanely detailed, beautiful 3D models on their own computers from scratch. How do graphics go from zeros and ones to characters on your screen?
With your character loaded, we need some video reference. Shoot yourself doing something silly, don't use that. And we'll use that. Drag it into Blender to load it as a background image and align it behind your character. Check that automatic keyframe button, then typically it's easiest to start posing with the center pelvic bone. Twist the hips a little bit, pose the legs by grabbing the foot controllers and some rotating. A little hip twist and then just move up the body, posing the spine to line up with the video reference. Then pose the hand controllers, move it around in 3D space to make sure it looks good at all angles. And then move about 8 frames forward in the timeline and adjust the rig as needed to match up with the video reference again. Mainly just using the hand controllers and the foot controllers. And now we have some character movement. Another 4 frames in the timeline and we'll need 1 more pose here. So jumping to frame 1 with the bone selected, copy the pose, move forward in the timeline and paste the pose flipped. Now just repeat this process for the other 2 poses we created. You can add a little variation here. Then to make it a perfect loop, just copy your first keyframe and paste it at the end and adjust the timeline. And with a little tender love and tweaking, there's our cringe-worthy animation. Render it out as an animation and send it to Pixar. And if you didn't catch all that, I also just posted a 25-minute beginner animation tutorial on CG Geek.
Oh my god! Wow!
In this video, I will show you the best settings on NVIDIA control panel for optimize your graphics card and get more FPS and maximum performance in your games. Hey, what's up? I'm Victor and welcome to another video of this channel. First, right click on the desktop and then select NVIDIA control panel. And now you must select the section Adjust Image Settings with Preview, then check the option Use the Advanced 3D Image Settings and click on Apply. After that, select the section Manage 3D Settings. The option Image Scaling allows you to have better image quality when playing with lower resolutions than your monitor's default. So you can get better FPS by reducing the screen resolution of your games without losing too much quality. For enable that feature, select the option On, then choose a percentage of sharpening and check the box Overlay Indicator to allow an overlay to appear in your screen whenever that feature is enabled. In Ambient Occlusion, select Performance. In Anisotropic Filtering, select Application Controlled. In Anti-Aliasing FXAA, I recommend that you select Off. Anti-aliasing gamma correction on, anti-aliasing mode, select application controlled, anti-aliasing transparency off, background application max frame rate off. In CUDA GPUs, select all of them. The option DSR Factors allows you to use upper resolutions than those supported by your monitor. For example, play games in 4K on a monitor that only supports resolutions up to 1080p. In latency mode, select Ultra for lower input lag and frame time in your games. In the option Max Frame Rate, you can limit the FPS in your games, but if you want to do that, I recommend that you do it in each game individually through the section Program Settings, right? In OpenGL Rendering GPU, select your graphics card, optimize for compute performance on. In Power Management mode, select Prefer Maximum Performance, Shader Cache Size, select Driver Default, Texture Filtering and Isotropic Sample Optimization on. In Texture Filtering Negative Load Bias, select Allow, Texture Filtering Quality, High Performance, Texture Filtering Trilinear Optimization on. In Threaded Optimization, select Auto. In Triple Buffering, you can select On if you play with VSync Enable. In Vertical Sync, select Use the 3D application setting, Virtual Reality Pre-rendered Frames, select 1 and save the settings by clicking on Apply. After that, select the section Configure Surround PhysX. In the option Processor, select a graphics card and lastly save the change by clicking on Apply.
A few moments later.
Oh my god!